while I was a student, I was growing up, I never had anybody to tell me why. I just used to cram it that when we are drawing alkene, we will just erase some hydrogen. I don't know how, I don't understand why, okay? But now you are getting to know the reason. Carbon does not have more than 4 bonds attached to it because it requires just 4 electrons to attain stability. While hydrogen must not have more than 1 bond attached to it because hydrogen is in group 1, all right? It donates 1 electron, or it's going to accept 1 electron as the case may be. So the oxidation of hydrogen is 1, and so hydrogen can only have 1 bond attached to it. Now, before I leave this, let me also talk about oxygen. Oxygen, hello, welcome to class today. So let's talk about hydrocarbons this morning. We're going to be looking at how to draw the structure of hydrocarbons. You remember hydrocarbons are alkanes, alkenes, alkynes. We're going to see how we're going to learn how to draw their basic structures. And so come with me to class. If you have not subscribed to this channel, do well to hit the subscribe button now and hit the notification bell so that you can be reminded or you can be informed anytime we post a new content, and do well to share this video with your friends, and whatever comment you have, do well to post in the comment section. If you have a question, post in the comment section. I will surely reply or respond to your questions. Alright, so coming. Now, the first hydrocarbon is the alkane. And for this alkane, the general formula for members of the alkane group is CnH2n plus 2. If that is the case, let's try to draw for the first member. The first member is methane. And the formula for methane will be what? C1H, 2 times 1, 2 plus 2, CH4. And remember the symbol for alkane is carbon single bond to carbon. Alright, so this is the symbol for members of alkane. So if I want to draw this down, it will be 1. So this is methane, CH4. This is methane. Let's draw for the second member, ethane. Ethane is C2H6. That's going to be 1, 2. Then 1, 2, 3, 4, 5, 6. So that is C2H6. 1, 2, 3, 4, 5, 6. If I want to draw for, let me pick hexane. Hexane is C6H14. That will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 14 hydrogen around 8. So I can name this normal hexane, N-hexane. Okay, so let's try to look at the alkene. You remember the formula for alkene would be CnH2n, and the symbol is carbon double bond to carbon. So and you remember there is no first member in the alkene group, so there is nothing called methane. The first member is ethane, so eth is the first member. Now let's draw for ethane. The formula will be C2H, 2 times 2, 4, C2H4. That's the chemical formula. So if you want to draw for this 2 carbon, 1, 2, you remember the symbol is double. So now let's see 4 bonds. Oh, sorry, 4 hydrogen must be attached. So let's see 1, 2, 1. Is this correct? No, this is not correct. Why? Because C2H4, how many hydrogen do we have? 1, 2, 3, 4, 5, 6. How come we are having 6? This is not correct. So we have to do something, and that brings us to the knowledge of the periodic table. If you have not seen my video on the periodic table, check the description below. You see the link to my class on periodic table. Now from the periodic table, carbon is in group 4. And carbon needs 4 electrons to attain stability. 4 electrons to attain stability. What that means is that carbon must not have more than 4 bonds directly attached to it. Carbon must not have more than 4 bonds directly attached to it. Okay, so if you look at this carbon, let's see how many bonds are attached to this carbon. 1, 2, 3, 4, 5. So that rule has been broken. So that means this cannot work. Therefore, one of these we have to go. So how many bonds do we have attached to this carbon now? 1, 2, 3, 4. 4 bonds are attached to this carbon. So this is perfect. This place 1, 2, 3, 4, 5. No, one has to go. And that is why you have 4 bonds attached to this carbon, because carbon cannot have more than 4 bonds attached to it. You know, while I was a student, I was growing up, I never had anybody to tell me why. I just used to cram it that when we are drawing alkene, we will just erase some hydrogen. I don't know how, I don't understand why, okay? But now you are getting to know the reason. Carbon does not have more than 4 bonds attached to it because it requires just 4 electrons to attain stability. While hydrogen must not have more than 1 bond attached to it because hydrogen is in group 1, alright? It donates 1 electron, or it's going to accept 1 electron as the case may be. So the oxidation of hydrogen is 1, and so hydrogen can only have 1 bond attached to it. Now, before I leave this, let me also talk about oxygen. Oxygen is in group 6. Oxygen has 2, or is deficient of 2 electrons. Alright, so oxygen needs 2 electrons to attain stability. So when you are drawing a structure and you have oxygen in the mix, there must not be more or less than 2 bonds attached to oxygen. The same for nitrogen. Nitrogen must not have more or less than 3 bonds attached to it, because nitrogen is in group 5 and it needs 3 electrons to attain stability. So this is for ethane. Alright, so let me give you an example of what I just said for oxygen. If you want to draw for the carboxylic group, COOH, you want to draw this, you will see something like this in your option. Option A, C, option B, option C. There you have option D. And they ask you which of this is correct. Can you see from here how many bonds are attached to carbon here? Let's count. 1, 2, 3, 4, 5. So this cannot be correct. How many bonds are attached to carbon here? 1, 2, 3, 4. Yes, 4 bonds to carbon. But then let's check how many bonds are attached to this oxygen here. 1. That is not possible. So carbon needs 4 bonds. Oxygen needs 2 bonds. Hydrogen needs 1 bond. Nitrogen needs 3 bonds. Okay, so let's check for this. Carbon, how many bonds is carbon having here? 1, 2, 3, 4, correct? How many bonds is this oxygen having? 1, 2. Okay, see, 2 bonds are attached to that oxygen. Okay, 2 bonds are attached to that oxygen. How many bonds are attached to this oxygen? I know somebody will say it's only 1. It is not 1. Why? Because between oxygen and hydrogen, there is 1 bond. So it's like this. Alright, so can you see? Oxygen has 2 bonds here, and hydrogen has 1 bond. So this is the correct answer. For this, carbon has 1, 2, 3. Not possible. So this is the correct answer. Is that okay? Let's continue with the alkenes that we're talking about. Let's try to draw for alkenes. So that's the number 1. Number 2, let's draw for propene. Propene will be C3H6. So that will be 1, 2, 3. I can put my double bond anywhere, so I put it here. So I need 6 hydrogen. 1, 2, 3. Can else count for hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. 8. But it's meant to be C3H6, so that is not correct. So we are going to remove 2 hydrogen. So from here, how many bonds are attached to this carbon? 1, 2, 3, 4, 5. No, that is not possible. So I can remove here. How many do I have? 1, 2, 3, 4 around this carbon. How many do I have around this carbon? 1, 2, 3, 4, 5. No, it's not possible. I've got to remove 1. So I have 1, 2, 3, 4 left. Correct? How many do I have around this carbon? 1, 2, 3, 4. So let's now count the number of hydrogen. 1, 2, 3, 4, 5, 6. So this is correct. Okay? So if you want to name this double bond is after carbon 1. So this is going to be prop 1-ene or 1-propene. Right? And when you are naming, I've done a video on how to name organic compounds, nomenclature. Check the description, you will see the link to the video. Go watch it. So you're supposed to start naming from here. Why? Go check the video. Alright? Number, let's pick one more. So let's try to draw X2A. X2A will be 1, 2, 3, 4, 5, 6. Mind you, X2A means 2-hexane. So the formula should still be 6-H12. So we are meant to have 12 hydrogen. 1, 2, 3, 4, 5, 6. So And on carbon 2, that is where the double bond will be. That is why it's called X2A. So 1, 2, I can put it here. And if I want to start from this and 1, 2, I can also put it here, whichever one. So let's put it here and I'll draw the other one. So this is 2 here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I hope you know why we left these spaces. So how many bonds are attached to this carbon? 1, 2, 3, 4. How many bonds are attached to this carbon? 1, 2, 3, 4. So that is why we are leaving this. This is correct. So this is X2 here. And you can decide to draw it the other way, starting from here. We have 1, 2, then your double bond will be here. I want you to draw that. And yes. So if you are drawing it, it's meant to look something like this. 1, 2, 3, 4, 5, 6. 1, 2. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so this is it. You're starting to count from 1, 2, so this is X2 here. Alright. Let's go to the alkyne. Remember the formula is CH2N minus 2. Alright. So let's pick, there is no first member methane, there's nothing like methane, but you have ethane as the first member. Ethane. That would be C2H, 2 times 2, 4 minus 2, C2H2. And remember the symbol for alkyne is triple bond. Carbon triple bond. So that's going to be 1, 2, 3 to carbon. Now, this is 1, 1. You know, 3 bonds from here are already joined to carbon, so it needs one more bond. This is it. And this, so this is C2H2. Then let's pick butane. Butane, that is 4 carbon, that is C4H, 2 times 4, 8 minus 2, 6. How do we draw this? 1, 2, 3, 4. I can decide to put my triple bond here. So I already have 3 bonds attached to this, I'll put 1 more. How many bonds are attached to this carbon? It's already 4. So I'm not going to add anything here. This is already 4, nothing to be added here. This is 2, so I have 1, 2. And this is 1. So how many do I need around here? 3. 1, 2, 3. So let's count now. This is 1, 2, 3, 4, C4. How many hydrogen? 1, 2, 3, 4, 5, 6. This is butane. Alright. And let's pick one more. Let's check pent 2 high. Pent 2 high. It's still pentine. So the formula will be C5H. 2 times 5, 10 minus 2, 8. C5H8. So 1, 2, 3, 4, 5. 1, 2. After carbon 2, I have my triple bond. Alright, so I have H8 left. So here, 1, 2, 3, 4, 5. I already have 4 bonds attached here, so I won't put anything here. I have 4 attached there, nothing here. I have only 1 here, so 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. And C5H8. So this is pent 2 high. So let me give you these 3 questions. I want you to go and try them out. So alright, so you can just attend those questions. I believe you got value today. If you have not subscribed to our channel, do well to do that right now. Subscribe to our channel. That is a way you can appreciate and support us. And do well to share the videos with your friends and your colleagues, right? And please hit the notification bell so that you can always be informed anytime we post a new content. See you in the next class. Bye for now.